So we can analyze this look ahead transformation in Z domain also. So analysis in Z domain, that is look ahead transformation. Okay, so again starting with the same filter, that is yn, that is equal to a of yn minus 1 plus xn, that is in time domain. Okay, and taking z transform both the side, we have y of z, capital Y of z, a into capital YZ, z of minus 1 plus capital X of z, that is in z domain. Okay, so rearranging the equation, we have yz, capital YZ by capital xz, that is also known as the transfer function hz, that is equal to 1 upon 1 minus a z inverse. Okay, so this, looking at this equation, it is having pole at z equal to a. See, so if I draw the location of pole in z plane, that is, this is x, this horizontal is real z axis, this is imaginary z axis, and this is, let's say, region 1, considering that if a is less than 1, it is having pole at z equal to a. Let's say this is a. Okay, so for stability, this a should be less than equal to 1. Now taking the equation, when we have applied transformation, so we denoted by m equal to 2, look ahead transformation, we have yn is equal to a square yn minus 2 plus a of x n minus 1 plus xn. This is in time domain. And in z domain, yz will be 1 plus az minus 1 divided by 1 minus a square z minus 2, and that is equal to 1 plus az minus 1 divided by 1 minus az minus 1, 1 plus az minus 2. So poles, this is minus 1. So this is having poles at A, and second pole is at minus A, and 0 is at minus A. Okay, so drawing its location of pole and 0, I have, this is real z, this is y-axis is imaginary z. So pole at location A, like in this circuit, and second pole is at minus A. So let's say this is minus A, and 0 is also at minus A. So 0 is denoted by a circle. Okay, so they are cancelling poles and 0, cancelling poles and zeros. Okay, because these two factors can be cancelled out. They are cancelling poles and 0. Okay, coming to equation 3, that was yn. Yn was equal to a cube y and minus 3 plus a square x n minus 2 plus a x n minus 1 plus xn in time domain, and taking z transform, hz will be equal to 1 plus ez minus 1 plus ez minus 2 divided by 1 minus e cube z minus cube. So now poles can be calculated from denominator. So poles are at z equal to a and z equal to, second pole will be at z equal to e raised to power j 2 pi by 3, and third pole will be at e raised to power minus j 2 pi by 3, or this can be also written as e raised to power j 4 pi by 3. Okay, and zeros at, okay, this equation is same as 1 plus ez minus 1 plus ez minus 2, 1 minus a z inverse, and this factor 1 minus az minus 1 plus az minus 1 plus az minus 2. This multiplied by this gives 1 minus a cube z minus 3. Okay, so these two are same. So zeros will be also at same location, that is e raised to power j 2 pi by 3 and e raised to power j 4 pi by 3. Okay, so to calculate the poles and zero, you have to revise a little bit of control system and Z transform for this. And now generalizing, this was for m equal to 3. Generalizing for m. So if I draw this on the real and imaginary axis, that is in Z plane, that is real Z, imaginary Z. So I have a pole at Z equal to A, and this is A times E j 2 pi by 3 is minus of A by 2 plus root 3 by 2 I, and A of E j 4 pi by 3 is minus A by 2 minus root 3 by 2 I. So something at this point, pole at this point and pole at this minus A plus root 3 by 2 minus A minus root 3 by 2, and zeros at same location. Okay, so denoting it by red circle. Okay, so these are cancelling poles and zeros. Cancelling poles and zeros. So now I can generalize it for m, any value m. Generalizing. So to perform m level of look ahead transformation, and in other words I can say that m level of pipelining in a given IIR filter, we have to introduce, okay, here you can see that for m equal to 2, one cancelling poles and 0 was introduced, and that was done by multiplying numerator and denominator by same factor accordingly. For m equal to 3, two cancelling poles and zeros were introduced, and that was done by multiplying numerator and denominator by same factor. So for m level pipelining, we have to introduce m minus 1 cancelling poles and zeros. Okay, and the equation will be denoted by hz will be denoted by 1 plus summation I equal to 0 to m minus 1 e of I z of minus I divided by 1 minus e of m z of minus m. So this will be the transfer function. Okay, and the poles and zeros will be introduced at, so cancelling poles and zeros will be introduced at location. Okay, and m minus 1 cancelling and poles will be introduced at location z, that is equal to e times e raised to power j 2 pi by m, e times e j 2 pi by m into 2, a times e raised to power j 3 times 2 pi by m up to a times e raised to power j m minus 1 into 2 pi by m. Okay, so this can be written as a e raised to power j I into 2 pi by m for I equal to 1, 2 up to m minus 1. So total m minus 1 cancelling poles and zeros.